Hi, it's Rob from Innon here, and in this video I'd like to introduce you to a product called Milesight. Now Milesight is a range of LoRaWAN sensors, a LoRaWAN controller and a LoRaWAN gateway, and the idea is to get data from the field wirelessly into your Niagara 4 station. Now all of these devices they broadcast LoRaWAN and they can be picked up by any LoRaWAN gateway, and anyone could use that to go to the cloud, but we're marketing this system to specifically get data wirelessly into a Niagara 4 station. So there's lots of different wireless protocols out there. Why have we chosen LoRaWAN? Well, there's three really good properties that LoRaWAN has that suit its use in the built environment, which is it's very low power, so the battery on these devices can typically last for about 3 years. It's long range, that's where the bit of LoRaWAN comes from, and also it's got good penetration through solid objects such as concrete slabs and walls and things like that you find in buildings, so that the sensors can successfully transmit their data back to the gateway, which might be in a riser, for example. So, okay, before we go into detail on each of the different devices, I'd just like to show you a little presentation just to explain basically how these work together as a system and get data back to your Niagara 4 station. So let's go and have a look at that. So let's have a look at how the three elements of the system fit together. So on the left here we have a LoRaWAN sensor, in the middle the LoRaWAN gateway, and on the right the Niagara 4 platform station represented by that picture of a Jace. So the first part of the jigsaw is for the LoRaWAN sensor to transmit LoRaWAN data, which could be temperatures, humidities, CO2s, over to the LoRaWAN gateway. It will receive that as LoRaWAN data. It will then repack it into JSON data, and then it will push it as a HTTPS post to the Niagara platform and station. In there is our Innon HTTP API and JSON modules ready to receive and decode that data. So let's have a little bit of a closer look at how the data comes into the JSON and how it is decoded from the JSON data. So at the top here on the left is a text HTTP servlet. This comes out of our Innon IoT HTTP module palette. So basically it's a servlet, it's waiting for a servlet rather, it's waiting for a client to come and post a message into there. And you can see the data there coming from a LoRaWAN sensor via the gateway. The first component we have out of the JSON palette, the JSON kit palette rather, it's called a JSON queue. It's just to queue up the modules if they're flooding in too quickly. This will calm things down and put them through in an orderly fashion, make sure they all get processed. You feed that into what's called a JSON router. This is very clever in that it can see what's called the EUIs from the sensors, like the unique codes that you would have put in a schedule so you know where they're coming from, and it automatically creates slots for each one of them in this component for you. You don't have to create these yourselves, it's quite clever. Once you've done that, then you feed each device or each of one of your LoRaWAN sensors, or their data, we should say, into a JSON demux, and this looks at each sensor. So this JSON demux component, it looks at each sensor's data, and then it creates automatically for you a slot for each piece of data. So you might have CO2, temperature, humidity, and all the rest. This is coming from a CM300. It's got a lot of data there, but it creates a slot for each piece of data. Now each of these slots can then be connected to another standard Niagara component, say a kit control component downstream in your wire sheet logic, and then you can also create histories and alarms and put extensions like that on it and treat it just like any other piece of Niagara data. So this would be a good point to explain the differences between our Niagara modules and Tridium's Niagara modules that do HTTP and JSON. Now our HTTP servlet module can only accept posts, it can't accept GET commands. The Tridium one can do both, and the JSON kit is only designed to decode JSON data. It can't encode your Niagara station into JSON data. So if you need to do those two things, which is receiving a GET command from a client into your JSON or your Niagara station, or you need to encode your Niagara 4 station data into JSON, you'd be better off using the Tridium Niagara modules. So now you've had an overview of the system as a whole, let's go into a little bit more detail on each product. So let's have a closer look at each of the devices in the range. First thing we've got here is a AM103, which reads temperature, humidity and CO2. This is the one without the display. There's one with a display, which shows all the different readings I just told you, a little graph for CO2, and there's a little emoticon on there which is linked to the CO2. So when you get too much CO2, it goes sad. When you're at the right level, it goes happy. It's also got a little traffic light there, which can be linked in the same way as the emoticon. Next up, we've got a AM104, slightly different style. So it's got all the things that the last one we said had, but it's also got light level. It's got barometric pressure, like the atmospheric pressure in the room. It's got VOC and motion as well. Now you can change the display on this a little bit. There's by pressing the power button on the back, and it will just make the display change a little bit. You can remove the graph and show more sensors and things like that. So it's got a little option to do that as well. So the next one we've got is an AM300. This is a lot bigger, as you can see. The display is a lot more easy to read, I think. And it's got some additional features to the 104, which is it can do PM 2.5 and PM10 particulate monitoring. It also has formaldehyde, which is basically the chemicals that are given off by building materials like tiles, and that can contribute to sick building syndrome. So it's a very good thing to monitor specifically, in addition to your normal VOC, volatile compound monitoring. It does ozone, which is very good in this day and age when we've got COVID-19 problems and people are putting these devices into their AHUs and rooms to destroy the COVID bugs. But these devices are electrical and they can create ozone, which is not good for human beings. So that's another good thing to monitor. So they're the ambient sensors, as we call them. They go into rooms in buildings to check, the conditions that people are working and living in, to make sure they're happy and healthy. So the next one we're going to look at is more to do with presence detection. Now this is the VS121. It's essentially a little camera, and what it can do, you can program this. You use an app on a phone, you can direct it to specific areas of a room. Say you just want to look at the breakout area, but you don't want to look at the corridor. You can draw little lines for it to specifically look at, to count people, how many people in the area. And also you can do a line crossing count, how much footfall there is through a particular area of a building. So the next device is a controller. Now this really is a controller. It's got digital inputs, analog inputs. It's got a couple of digital outputs that can be read and transmitted back using LoRaWAN back to the gateway onto your Niagara 4 station. It's also got Modbus. It can read Modbus RS485 as a master, so it can read a number of slaves for you, push that data back to the gateway. And it's also got some logic in it, some very basic logic, but it can actually operate the digital outputs according to temperatures and statuses it's reading on its digital and analog outputs. And it can actually those outputs can additionally be commanded using a downlink from your Niagara 4 station as well. Also, it's got an RS232 port on it, so you can attach a device that has RS232 connectivity, and it can read the comms coming through on that port. It can't do much with it other than just push it in its raw form up to the gateway. So all these devices obviously have a battery because they're wireless. Some, like this one, can actually have a DC power supply as well as a battery. But the battery life, if you're running them on batteries, is typically about 3 years. Okay. Also to mention, they've all got NFC, which means you can use a mobile phone with an app, and you can use that to communicate with the device locally when you're commissioning, and you can set up different configuration parameters, such as how many times it should transmit. Obviously, the less it transmits, the less battery life it uses, so you set that according to your application. And also, they've got a QR code on the back, and that can be read, and the app can read that and take what's called the EUI number, which is its unique wireless LoRaWAN number that you need to register it with the gateway. So that makes commissioning and setting things up and recording, filling out schedules of devices quite an easy little task, which is a nice feature. We've seen all the different sensors and how they transmit data. Obviously, we need a gateway to pick that up and then send it on to our Niagara 4 station. And this is the device that does that. It's a Milesight UG65 gateway, LoRaWAN gateway. So this obviously reads all the transmissions from the sensors, receives them, and then as long as you register the EUI number in this device, it can then take that data, and what it does, it encodes it into JSON formatted data and then pushes that up to our Niagara 4 station, be that in a JACE or on a web supervisor. Okay, so the reason we encode it in JSON is at the other end in the Niagara 4 station, we can provide you with JSON decoding modules, Niagara modules, and an HTTPS server module that receives the data. So that's why we're encoding it into JSON. So also to say, this has MQTT functionality on it. It can be an MQTT client. It can push that data up to a broker locally on site or in the cloud. But for our application that we're marketing, we're using the HTTPS server with all our Niagara modules that we can provide you to put into your JACE or your web supervisor. So obviously this needs to connect to the JACE in some way over the IP network, and it can do that using Ethernet or Wi-Fi. So there's some other little extra features on this device, just to let you know what those are. It can do VPN, VLAN, it can do cellular network failover if you fit a SIM card into it. It can do SNMP, SMTP, sending emails and things like that for alarm statuses. And it also has the functionality to do Python and Node-RED applications inside here. If you want to get into interesting little things like that, if that's your sort of thing, this device can do that. Well, I hope you found that interesting. If you'd like to learn a little bit more about these products, please head on over to innon.com, where you can access our support site, where you can access all the data sheets and manuals for each of these devices. Also, you can access a knowledge base there, and there's some specific articles related to this product range. So thanks for watching, and see you in the next video.